This is example 20, part B. All right. So here's the question. 8x squared minus 19x plus 1 over this. So partial fractions again. And the thing is, as I said in the previous video, when you can factorise the denominator into linear terms like this, then it's always partial fractions. So the method is here. Okay, I'm just putting it up on this board for you. There we go. So yeah, can you see? Just write it out like this. Remember, with the repeated factor, you've got to have both an x minus 2 and x minus 2 squared, so you've got the 3 terms there. Okay, so when you set this equal to this, as a reminder, remember, if you treat that like an equation, it's an identity, but treat it like an equation, you can multiply both sides by 2x plus 1, x minus 2 squared, can't you? So when you multiply this term by 2x plus 1, x minus 2 squared, you're just left with a, x minus 2 squared. When you multiply this term, you're just left with b, 2x plus 1. Multiply this term, you're left with that. And then you've got that is equal to the numerator. I just can't fit it all on. And then x equals 2. When you put it in, you'll get b is negative 1. X equals negative a half. You put it in, you get a equals 2. But then there's no other sensible value of x you can substitute in order to get the brackets to be 0. So just put in x equals 0 is the simplest thing. Okay? And then you should be able to get c equals 3. So hopefully, if you needed to, you've paused the video and you've had a look through that. It's important to get the partial fractions bit right. But as I said, it is a recap. The new bit essentially is, or for you in this chapter, the integration of it. Okay. So having got the partial fractions, this can be written as this: 2 over 2x plus 1 subtract 1 over x minus 1 squared plus 3 over x minus 2. Okay. Maybe just have a think about it and see how you integrate it. Okay. Done. Right, this one then, it's a natural log, isn't it? Okay. Can you see which ones are natural logs? I hope so. So this one and this one, they're natural log terms because you've got a single fraction with a term on the bottom there. That's effectively power of negative 1, isn't it? Whereas that there, you can see, because that's got a power of 2 there, that's a fraction power of negative, that's not a natural logarithm. So just those two natural logs. Okay. So this one here, that's going to be natural log of, remember, it's going to be the whole denominator, 2x plus 1. Now, what about the coefficient? Okay, well the 2 is there, isn't it? But then remember, when you differentiate what's in the brackets, you get 2, you've got to divide by 2, haven't you? Because you're integrating. So you've got the 2 that's there originally, and you've got to divide by 2, so you just get 1, natural log of 2x plus 1. Okay, and this term here, here, different colour. Just write that as x subtract 1 to the negative 2. Yeah? And then what you're doing is in these ones, you're raising the power by 1. So that's going to be x minus 1 to the negative 1. Yeah? X minus 1 to the negative 1. Let's just write that here and I'll rub it out in a minute. X, so we don't forget, x minus 1 to the negative 1. Divide by that power, of course. So that's going to be negative x minus 1 to negative 1. Subtract it, so subtract a negative, that's going to be plus x minus 1 to the negative 1. So plus 1 over x subtract 1 is the preferred way of writing it. Okay. And then the next one, that's a simple one, 3 natural log x minus 2. Simpler because you've got no coefficient in front of the x. Okay. Now, do we write plus c or plus natural log of k? I'm going to put plus c for the moment, and then maybe you can answer that question once I've gone through simplifying a bit. Because it is a good idea when you've got more than one log term to simplify it, right? So here, we can combine these together, can't we? Can you do that in one line without actually writing more steps than necessary? I hope so. So keep the modulus brackets, so you'll have 2x plus 1. Because we're adding that, we're going to multiply it, aren't we? But then the 3, you've got to use the power rule to make it x minus 2 cubed. X minus 2 cubed. Okay? And that's it for the log terms, isn't it? And then you've got the plus 1 over x minus 1 and then plus c. It makes no real difference, okay? You don't have to write that as natural log of k. You can do if you want, but the thing is, when you've got a term that's logarithmic and a term that's obviously not logarithmic, there's no real need. Okay, it's only when all the terms are natural logs then you might want to just for niceness, put the natural log k in. If you want to, obviously it'd be natural log of k times that plus 1 over x minus 1. I'm always interested to see how the textbook leaves their answer, because sometimes it's nice to comment on it, but yeah, they've gone for exactly the same as well. Oh, crikey. Yeah. Did you spot it? Yeah. Now, I've got a choice to make. Do I redo the whole video? Or do I just do that? Because in terms of the working, it doesn't actually make any difference. How on earth, how on Gallifrey, did I do that? Well, it happens sometimes, doesn't it? It happens sometimes. In class, I'm sure one of you at that stage would have said, oh, I'm sorry, sir, it should have been x minus 1. So maybe I'm going to leave it in. I won't record the video, okay? Because it kind of maybe gives us some flashbacks in class when sometimes that happens. And it makes it more real, doesn't it? Yeah, it makes it more real. Yeah, so I'll keep it in. I won't redo the video just for that, okay? I'll keep it in, okay? Yeah, like the post if you think, yeah, you're right to leave it, Mr. Brown. Or if you're purist, if you're like, no. You're still getting paid. You need to do the videos properly, mate. It's up to you. I'm going to leave it, okay? I'm just going to go to the next example, all right? I'm sure the doctor would agree with me as well. Yeah. Dr. Foreman, okay? Doctor who? Who's he talking about? Who said that? That's another quote. I love quotes. Who knows that with me? I love quotes. When I was a teenager, I used to watch a lot more TV than I should have done, really. Nothing changes, does it? Okay, but I've got all these floats in my head because I've just seen the things so many times, okay? But anyway, who said that? Okay, so it was like, I'll try it again for you, just in case you missed it, so you don't have to rewind. Okay, so I made a reference to Dr. Foreman, okay? So I said, Dr. Foreman, hey, Doctor, what are you talking about? Who said that? And who originally said Dr. Foreman? Who gave the name Dr. Foreman?